So today we're going to start our next projectile motion lab, and we're going to be using these little doohickeys right here. It's a projectile launcher. We've got a little tube here with a spring in there, and we can take this little metal plug and we can set it in there. And you'll notice it has two little notches on there. Now we're going to use this top notch. To load these and fire these, you're going to push down on the plug and you're going to feel the spring compress. And when you get it low enough, you're going to stick this little washer in there, have it just barely hanging in there, kind of like that. Notice it usually has a spring on the end of it, so that when you yank this washer out, the spring will uncoil and project or push that metal plug forward. So long as we do it through the air, we've got a projectile. And that's what this is all about. So here's what you're going to do. You're going to take this projectile launcher, you're going to set it up just like this, and we're going to put it on a table in J109. And you are going to fire the projectile launcher just like you fired your toy car. And the projectile is going to go off the table, and it's going to land over here somewhere. Now, that's going to go a lot further than your toy car did. So you're going to have to be careful when you set up the tables in the lab that you have a clear line of sight, that you're not necessarily launching into somebody else's lab area. So what data do you need? You need this Y value. You need the height of the table, which we already have from our lab from last week. You also need the range. You need the distance that the projectile lands on the floor. What you need to do is do this once again about 3 times. So we'll do 3 trials and get 3 data points, and hopefully they will all be very similar to one another. Now, if you get one data point that's kind of like way different from the others, either it was way short or way long, probably more likely to be way short if if the washer got stuck a little bit and the spring wasn't released necessarily very cleanly. Throw that data point out and go back and do another trial. From the height of the table and the distance traveled, we can do the same process that we did with our toy car, and we can find the velocity in the x direction, which is the velocity that my launcher shoots my projectile. And that's the point of this. Now, we're going to do this 2 ways today. This should be pretty quick because we've already done it this way. So it should be easy. What you're going to do the second way is you're going to take this, and instead of being at 0 degrees, you're going to put it at 90 degrees. So we're going to make all of the velocity in the y dimension. And we can do the same process with the y as we did with the x. But think about this. For the x, we had to measure where it landed. How far did it move in the x direction? Well, now we have to measure how far does it travel in the y direction. And we can do the same math. So what you're going to do is set this on the floor, out in the hallway or in some places in J109, and you're going to take a tape measure, you're going to hold it beside the launcher, and we are going to basically measure this way. So one of your partners is going to launch it, and somebody else is going to watch, and they're going to see how high does the ball or does the projectile get. Now remember, we only need the maximum height that it travels, and you must measure from the end of the projectile launcher. Do not measure from the floor, because the projectile didn't travel that distance. It traveled this distance. Once again, you're going to do 3 trials. This one's going to be a little bit more challenging to get 3 close data points, because you're kind of eyeballing how high that thing got, and then you have to measure. But you'll get 3 points that are at least close enough. So now what we're going to have is we're going to have a distance in the y, and we know an acceleration in the y. We know a final velocity in the y is 0, because we're going to measure it until it gets to its highest point. With this data, we can do the math a little bit differently, and we can figure out a velocity in the y dimension as it comes out of the launcher. the velocity calculated this way and the velocity calculated that way should be pretty close because it's the same launcher. It's got the same spring and it's launching the same projectile. So we should get the same velocity, or at least close, each time. So that's the goal of today. Today is collecting the data and then doing the math to calculate the velocity coming out of this launcher. And then tomorrow, we're going to start setting this launcher at an angle, doing the basic trig to figure out y and x velocity and predict where that will land when we launch it. So one other thing to consider, these launchers are marked, some of them with letters, some of them with numbers. You need to make a note of your particular launcher, because when we come back tomorrow, it's the same thing. You need to know what the velocity of this launcher is. And this one could be a little bit different than another one. Say the spring is a little more worn out in letter D than in this one, letter C, and that will affect your trials tomorrow. So once again, those of you at home, you need to pair up with a group that is here and get the data and go through the explanation of how you solve for the velocities together. You can do this via FaceTime, you can text back and forth, but those of you at home, it is your responsibility to get a lab group. If you cannot, I will assign lab groups, and I don't particularly want to do that. I want you to be able to work with people who you know and who are you comfortable working with. So that being said, let me know when you're done watching this presentation and we'll go into the lab and we'll get these and we'll start setting these up and collecting our data.